The universe is filled with stars like our Sun, rocky planets like our Earth, water like in our oceans, amino acids like those that make up our proteins, and all the other ingredients for life. But where should we look to find it? We live on a majestic blue planet called Earth. Earth is habitable because it has the right conditions to sustain life as we know it. A very important ingredient for life is the availability of liquid water. So, astronomers believe that planets that can hold life as we know it outside our solar system should also lie in a region where liquid water can exist. Around the star, there exists a region which has just the right temperature for liquid water to exist. This region is called the Goldilocks zone. The location of the Goldilocks zone or habitable zone of a star is found based on how luminous and massive the star is. The surface temperature of planets in this zone has to lie at a comfortable temperature between 0 to 100 degrees Celsius for liquid water to exist. Our Sun's habitable zone lies from Venus to Mars, with Earth sitting comfortably in the middle. The nearest star to our Sun, Proxima Centauri, has at least one planet in the habitable zone. But because Proxima is much smaller and dimmer than our Sun, its habitable zone is much smaller and nearer to the star. Every star has a habitable zone, but that doesn't mean there will be planets there. Since the concept was first presented in the 1950s, many stars have confirmed to possess a habitable zone planet. Most such planets, being either super Earths or gas giants, are more massive than Earth because massive planets are easier to detect. But to find planets that can hold life as we know it, we look for rocky planets with an atmosphere and not gas giants. Just as stars evolve, so do the habitable zones. Stars grow and shrink as they evolve. When they grow, the hydrogen present in them burns, leading to the buildup of helium in the core. This leads to an increase in pressure and temperature, which transmit outwards to the surface of the star. So they become brighter and hotter, and thus the habitable zone moves out with time. As the Sun nears its death, it will become a red giant, which means it will expand and inevitably engulf the Earth. Post the red giant phase, a new habitable zone will emerge, having Saturn's moon Titan in that zone. So how do we know if a planet has life or had life in the past? Biosignatures. Organisms inevitably leave their marks on their surroundings. These clues are known as biosignatures. For example, let's look at a plant. When it performs photosynthesis, it takes in carbon dioxide and releases oxygen, changing the chemical composition of the air. When it takes nutrients from the soil, it can affect the formation of minerals, and as the plant grows, develops, and eventually dies, organic material is released into the environment. These changes and patterns serve as clues to life's existence, and by searching for these signs or biosignatures, we can detect the possibility of life. The first piece of information that we can get from these distant planets is through light. In fact, majority of exoplanets are detected when they block a fraction of the light of their host star and cause a dip in brightness. This is called the transit method. Stars emit light in many wavelengths. During the exoplanet's transit, light from the star travels through the atmosphere of the planet, and some of the wavelengths are absorbed depending on what molecules are present. For example, nitrogen will absorb a different wavelength compared to carbon dioxide. So when we look at that planet in front of the star, some of the wavelengths that were originally there in the star will be missing. These dark absorption bands will serve as molecular fingerprints, helping us determine the composition of the atmosphere. These curves are called transmission spectrums, and scientists look for biosignatures such as carbon dioxide, methane, oxygen, ozone, nitrous oxide, among many others, to determine if the planet can harbor life. From the transit curves, we can determine the size of the planet, and from the gravitational pull of the star on the planet, its mass, hence finding the density. This will tell us whether the planet is rocky or gaseous, another important factor to check if the planet can hold life. We can only learn so much by staying on Earth. So, to get a better idea, we need to take a closer look at these exoplanets. The search for extraterrestrial life began after the invention of radio in the 1900s. The first ever mission where we actually landed a spacecraft on a planet in search of life was the Vikings mission in 1976. The biological experiments on the Martian soil revealed some unexpected chemical activity and even found evidence of ancient riverbeds and vast flooding. The search for life outside the conventional habitable zone began with the advent of the Galileo mission in 1989. The mission found evidence for a subsurface ocean on one of Jupiter's moons, Europa. In fact, this ocean has more liquid water than the total amount of water on Earth. Various telescopes like the Hubble, Kepler, Spitzer, and now the James Webb Telescope have scanned our skies for exoplanets and discovered a whole bunch of them, some of which could be promising places for life. Humans have always wondered what is out there, or who is out there. We have reached the stage where we not only discover planets, but can even study their atmosphere in great detail. Will our generation get to find life out there? Only time will tell.